Hello everybody! In this video we're going to write another version of the alternating function that we wrote in the previous video. This time we're going to check if the index is even or odd. So if we go all the way back up to our original goal, we want to create a function where it starts with 3 and then goes 7, 3, 7, 3, 7 until it has length n. And remember, Python starts indexing at 0, so this is index 0, 1, 2, 3, and so on. So what we're really doing is we want all of the even indices to have a 3 and all of the odd indices to have a 7. So let's see how we can do that by hand. So this is also going to be a good introduction to if statements in Python. So all right, let's start by writing def for our function, our definition. Let's call it alt2 for alternating 2. We still want to have an input of n, and we still want to initialize, oops, and what am I missing? I need the colon. I want my list to be initialized to be just an empty list. And now one thing I want to highlight is, let's go back up to our alt1 function. Notice here that we called constant n, which in turn was this function that we had written here. So even though alt1 kind of looks a little short, we're really needing to put in these 3 lines of code. So you can imagine here that this is really 3 lines of code. So maybe this alt2 is a little bit simpler once you take into consideration that we're not going to be calling our constant function. So everything's going to be kind of built in. So let's start by initializing an empty list. Now what I'm going to do is I'm going to say, okay, for I in range n, so I still want to have n entries. Now we need to check the indices. So I'm going to say if, and what I want to happen here is if the index is even, I want to append 3. So before we do that, let me show you how we can check even oddness in Python. So let's say I have I equal to 6. What I can do is I can say I%2. So what this percent means is modulus, so remainder when you divide by 2. So I can say, okay, what's the remainder of I divided by 2? It's 0. And what that means is that, yes, 6 is divisible by 2. I could do 7% 2. So what's the remainder of 7 divided by 2? Well, that's 1, and that means that 7 is odd. So there's only 2 possibilities when we're dividing by 2. Either it's divisible by 2 or it's not. So then that returns 0 or 1. And of course, these are the only 2 remainders possible, so that's why. So okay, let's say here. So for I in range n, now let's set the even indices. So if I%2 is equal to 0, and we need a colon still, I'm going to press return. Now notice the indentation again. So the first set of indentations tells me to enter the definition, the function. The second tells me to enter the for loop. And the third is going to tell me to enter the if statement. So if the index is even, I want to take my list and append 3. Otherwise, so else, and what I should do is bring this out, else, and what do I need? Colon, my list dot append 7. Now I can run this or I can save it, and it's not going to have an error, but what am I missing? Does anybody see it? I need to return something, right? So I don't want to return it in the else statement. I don't want to return it in the if statement or the for statement. I want it to be returned after I've gone through the for loop. So notice here that I'm lined up with where for starts. So because it's not indented inside of the for loop, I can return my list here, and it should work how I suspect. So let's try it. Let's do my list of 4. Oops, not my list, sorry. Alt2 of 4. And this looks good. 3, 7, 3, 7. Let's try it with an odd. 3, 7, 3, 7, 3. Looking good so far. And we could test it a couple times. It's always a good idea to check edge cases for your functions. But I think in this case, the main thing to check is that it works on even and odd input arguments. So, okay, we've seen this else statement. You might be wondering, okay, I've seen these else if statements before. And you could do it just as well here. So in this case, there's only two possibilities, right? Either the remainder is 0, and if it's not 0, then it has to be 1. But equivalently, I could say elif, so elif. And notice for else, I don't need a condition. So that's going to happen only if everything above it is false. But if I have elif, I have to give it a statement. So notice if I try running this, this is invalid syntax. I need to give it a statement. So otherwise, I'm going to say if I %2, so if the remainder of I divided by 2 is 1, then I want to append 7. And we can run and see that it works exactly the same way. So in this case, the if-else gave exactly the same results as the if and then elif, just because there's only two options. But just as before in the MATLAB unit, you could have as many of these elif statements as you want. So if you had a very complicated kind of sequence of things that could happen, you could have many of these. I could have another one here. I could say elif, oops, and let's bring it outside. Elif I%2 is equal to 17. That's never going to happen, but I could have something else here. So that's what I mean. So that's the way if, else, and elif statements work in Python. Thank you for watching. I think that's all I wanted to say in this video. In the next video, we're going to see yet another version of this function using a library called NumPy. So see you there, and thanks again for watching.